you should have already had the chance to write your electron configuration and in your engage program, and you should have boxed the last s orbitals and any p orbitals that followed. So in our examples here, we would have boxed our last s, and even though there is a p, it's not after the s, so you should not have boxed it. And then on boron, you boxed your last s, there is a p after it, so you should have boxed that one as well. So when we look at this and we add up our superscripts, this should have been 1, and this would have been 2 plus 1, which is 3. And these are your valence electrons. Okay? So that's what you should have gotten out of your engage. Okay, so you should have, or you may have, actually started to recognize a pattern as you traveled across the periodic table. And that would be that you start to see that all of group 1 has 1 valence electron. And all of group 2 has 2 valence electrons. Okay? We are actually going to skip over this whole center section because it gets a little wonky. But when you get to 3, the rules do change a little bit. Okay? While this is actually group 13, it only has 3 valence electrons. So you kind of drop the 1.
Okay.
Okay? So group 4 or 14 has 4. 15 has 5, 6, 7, and 8 as you go. Okay, so the maximum number of valence electrons that you can have is over here on your noble gas column. You can have 8 and you're full. So you can't have any more valence electrons than 8. Okay, so once you know this, then it's pretty simple to just identify how many valence electrons you have, right?
Yeah, but why would I need to know? Why would I need to figure out how many valence electrons I have?
Well, one of the things that this is really good for is drawing Lewis dot structures. And that's basically where we take it and we can show just the symbols with the valence electrons, which are the only parts that are really important as far as bonding is concerned. So what we're going to do is you take whatever symbol you have. Oops. Okay, so you take your symbol. We're just going to make a random X at this point. It's not actually representing xenon. And you take the number of valence electrons and you place it around the symbol according to the compass, the points of the compass. Okay, so those are your 4 points. And you're going to add the dots one at a time as you go around. Okay, so once you have all 4, you would go in and you would add your second one so that they have a partner, and they only go up to 8. Okay, so just like we said, the noble gases only go up to 8. Our valence electrons only go up to 8, so dots can only go up to 8. Okay, now if the number that you have for valence electrons is not 8, then you would simply stop at wherever you were. So let's say we had 6, we would have stopped at 6. Okay?
So I can't just, if we've only got 6, I can't just, may I?
Yeah.
I can't just say, if this is our element, I can't just go like this. Hi. I mean, that's 6 right there.
Right. We can't do that because it doesn't follow our rules. So what we'd have to do is we would have to take our symbol,
Okay.
add our 1, 2, 3, 4, 5, 6. Okay? So we have to have everybody, just like when we were doing our electron configuration before,
Oh, that's right. You could
Yeah.
only put in
one.
one arrow in each space,
Right.
and then you went back.
Exactly. So everybody's
Okay.
got to have one before we can give them their partner.
Okay.
Okay, so this is actually what 6 would look like. Okay?
Awesome.
For instance, if we had, let's say we were doing nitrogen. We look on our periodic table, we see that nitrogen is in the 15th column. 15 is how many valence electrons?
I don't have. I can drop the 1, so 5.
Exactly. So we can go 1, 2, 3, 4, 5. And that's it for nitrogen. That's nitrogen's Lewis structure.
Okay.
We talked about one having 6. Well, oxygen is in the 16th column, so it has.
6.
And so this is actually what oxygen would look like. Okay?
Okay.
And it is a big deal that you don't draw it like this because it kind of messes up the bonding. Okay? So the order is important, and they do have to look like that.
Okay.
Okay?
Cool.
If we had something like Li that was in column 1,
It would only have one valence electron, so we'd only have one dot.
and that's it.
Okay.
That's all it would have.
That's pretty easy.
Yeah.
That was a whole lot of information. Is there a way maybe we could kind of summarize it or put it all together?
Yeah, let's go ahead and make a nice list that has all those rules on it for us.
That's a good idea.
You might want to copy this down, guys. Okay, so I